So here are all the things I'm going to be using for this project. So of course we got the ESP for the 2 reverse TFT board, and then this is the motion sensor from DigiKey. It's a feather wing, so it has the same size, and we'll make a sandwich out of that. We have a LiPo battery, Adafruit sells LiPo batteries that are 400 milliamps. That is made to go in between here. That will work. I managed to find a 500 milliamp LiPo battery inside of a disposable e-cigarette, so I'm going to be using this because it fits perfectly. Some headers. These are 2 short header sets stacked together. A power switch, some wire so I can make some jumper cables, a breadboard so I can prove things out, and then this screw set from Adafruit to basically secure the corners a little bit. These are kind of optional, you don't strictly need them. Some rubberized something to go to make feet. I bought these from Adafruit, but I think they're too big, so I might just use this squishy software, squishy bits. Some flush cutters is always good to have, and of course you will need a soldering set as well. So the first thing I do is that I assembled everything without doing any soldering. These headers aren't soldered, just to give me confidence that I thought through everything, that looks right, and I know what I'm going to be doing. Especially you need to pick the right headers here to give enough space for the LiPo battery. You can see just in there that the main board stemmer port is the thing that's jutting out in the middle, and that is going to start pushing into the battery if you don't give enough space. So with a normal headers like this, I can't completely push these 2 headers together because there's not enough room, the battery is in the way. So what I'm going to do instead is that I take these shorter headers, stack them together, and that makes it slightly bigger, about 1 millimeter, and that's all I need to give the battery enough space. So I'm happy with this. Next step is to solder in the headers so that I can then plug it into a breadboard and prove out the wiring and the programming. First I soldered the short header pins to the DigiKey board. Make sure you get the direction right. So this is going to be the bottom that points downwards, so the spike should go up like this. And to do this easily, just take the headers, attach them to a breadboard, and then lay the board on top of them. Maybe tack them down with some pieces of tape to make sure the board doesn't move, and then solder them on. Adafruit has a nice little guide about how to solder male header pins onto a board. Just follow that. So now it's time to solder the short female headers onto the TFT. So I'm tacking them down with tape to make sure that they're absolutely 100% straight. Then I'm going to make the first little solder joints on the corners, then I'll remove the tape and do the rest of the soldering. So I've soldered on the female headers onto the display board. I ended up using headers like this, so I could stack this on top to keep it steady, and also used a little bit of tape to make sure that the headers went on straight and nice. So let's go and test this, make sure I got the soldering right. So I want to make sure that the soldering is done okay, so I stuck the 2 pieces of the sandwich together, ran the stock code for the accelerometer, and it seems to be working. So great. Now let's move this over to a breadboard so we can prove out the rest of the wiring. Okay, so here we have the breadboard wiring of all of the components that we'll be using here. So let's do this in turn. These middle ones here are just basically connecting the left and the right board the way that they would be connected if we turn the sandwich over and connected them together. So we can ignore the green, yellow, this long red wire, and the ground here, because they will be connected automatically. But there's some other wiring we should talk about. So first of all, we've got the battery. I run the battery to this line here, and then over to the battery pin. And then the ground goes to a common ground line over there. In order to turn the device on, I've connected the enable pin via the switch to ground. So now if I switch this on, I can see that power comes on. The little sound you heard there was this piezo buzzer that I connected to the analog 1 pin and then to ground. So that allows me to play little notes. The other thing that's interesting here is that I have this, I've connected the interrupt pin on the DigiKey accelerometer to A4. And what that allows me to do is to interrupt, I can go into light sleep and then wake up if there's movement. So if I tap this, it wakes up and it can do something. So I can detect movement, which I will be using in the code later. And that's pretty much it for all of the wiring and the features of everything. I proved out that it works. Oh, one more thing. If I connect the USB cord here, get in there, then we can see here that the charging light came on. So I've also proven out that I am able to charge the battery via the USB. So that's it for proving out the wiring. Next up is to actually put it all together without this horrible mess of a breadboard. Okay, so I just super glued the switch onto the board here. Things to keep in mind is that those two little tabs there is part of the switching mechanism. So when you do this, I recommend putting a little bit of tape over those on the underside, the one that you're going to glue, so that you don't super glue the mechanism together. And be really quick. And then while it's drying, I think it's a good idea to keep flicking the switch back and forth. So if there is a teeny tiny little bit of super glue in there, it kind of gets, it doesn't cure and ruin it. So this is very sensitive. I also used masking tape to cover up the holes here because we want to put screws through them. And it also helps to center it because you can more carefully mark out exactly where you want the switch. I screwed up a little bit. It's a little bit off center, but it's fine. So I have my switch. So time to solder up some of the connections. I'm going to do 2 solder joints first. First is the interrupt jump here. I'm putting the cord this way so that there's not a sharp solder mount sticking into the battery from this side. I want that smooth and nice. And then I'm going to do the ground cable for the switch. I'm soldering here, leaving quite a long piece of wire here that I can then solder onto for the battery later on. I'm using the blue masking tape here to hold everything in place, and what I have here is a little jumping cable that I made that perfectly reaches the pin on the power switch. And note that I've cut the power switch teeth down to size, about half, so that later I will have space to put the piezo buzzer there. Alright, so let's cover that back up and do some soldering. Okay, now I'm doing the power pin. So it's a pin that's not connected to anything, but I just want it there so that I can then solder the battery's power lead onto it. And I want to do it first now, so that I know how high this one is going to be, so that when I put in this is the enable pin, it can go over this hump and to the middle leg of the power switch. So let's do these two. Okay, now we've added the enable pin, the yellow wire, and I made a pin for the battery to be attached to here in a little bit, that one there. So next step is to tack on the piezo buzzer there, and the black wire needs to be soldered together with the ground wire at the same time onto the switch, and the red wire is going to be going in there. So I will need to trim these wires quite a lot and also expose the metal and then solder them together. Okay, so now I've attached the piezo buzzer. I put a little solder point there which connects the ground to this black wire of the piezo buzzer. So the ground is reaching everywhere, it's reaching the connection here and the piezo. And then the red wire there just connects to this pin on this side there, right there. So now it's just a matter of hooking up the battery to this pin and that pin. Okay, well, I just tried to put this together, but it's not working because the interrupt jump cable is too thick and it makes me not be able to close the sandwich because the battery gets stuck in the middle. So I'm gonna have to replace that white jumper cable with a thinner cable. Maybe something as thin as this. Well, and hopefully that won't take up so much space. And now for the final step, soldering the battery to the power and ground pin. So I use masking tape to hold the wires close together while I do the soldering. Okay, so here is the final remote control put together. So the battery is in there and it's closing just fine. I put little pillars on the corners here to mostly for aesthetic reasons, but also to just support the board. Can't do it on this side because the mounting holes here and here don't line up, unfortunately, because of the antenna here. But that's fine. I put little screws here so that I would have equally large feet on both sides. And then I put little 3M sticky tape in order to make it not slide around the table too much. So let's turn it on. Got the power switch here. And we can see here that that is the interrupt from the accelerometer. So it can read the accelerometer, the interrupt pin is set correctly, and we can clearly hear the piezo buzzer buzzing around. So yeah, now it's just time to program it to do something interesting.